The 1970 oil crisis began in October of 1973 when the members of OPEC proclaimed an oil embargo. By the end of the embargo, the price of oil had risen from $3 per barrel to $12 per barrel. Gas customers had to wait in line to purchase gas, and often the station would run out of gasoline. As a result of the rise in prices, consumers started to consume less petroleum. The graph below shows two functions. The top function represents the rate at which petroleum was being consumed before the embargo. The bottom function represents the rate at which petroleum was being consumed after the embargo. To determine how much petroleum was saved and predict how much would be saved in the future, we use integration. In Calculus 1, you learned that the integral can solve for the area under a curve down to the x-axis, provided the curve is always above the x-axis. To find the area between two curves, we need to integrate both of the functions. F of t is equal to 0.12t squared plus 18, and g of t is equal to 0.6t plus 19. But then what do we do? If one person is 6 foot tall and another is 5 foot tall, we subtract 6 minus 5 to determine the difference of their heights. In the same way, if one function is higher than another, and we would like to find the difference in their heights, we need to subtract the two functions. Since we're trying to find area, it is important that we get a positive answer. You certainly wouldn't go to the hardware store and say, well, I have a wall over here I'd like to paint, and it measures negative 100 square feet. Looking at the graphs of f of x is equal to 10 and g of x is equal to 6, we need to subtract the smaller value of 6 from the higher value of 10 to get a positive result of 4. That process holds for more complex functions. As shown in the next set of three graphs, if we find the total area under f and subtract the area under g, we will get the net area between the two curves. Said simply, top function minus bottom function is what we always want to do to find area. Now let's return to the equations for the amount of petroleum saved. The petroleum saved will equal the integral of the top function minus the integral of the bottom function. To make our work a little easier, we combine the integrals so that we can gather like terms. Finally, we use the rules of calculus to integrate. In summary, the most important thing that you need to do is graph the two functions and determine which function is higher than the other. Then it's a simple process of taking the top function, subtracting the bottom function, and integrating to find the area under the curve.